News reporting, storytelling, slideshows, training videos, web presentations, and advertisements are just some of the types of media where voiceover is an essential element. Producing a good voiceover isn't difficult to do, and the gear you need to pull it off is fairly inexpensive. The quality of your voiceover, however, will only be as good as your ability to control the sound and your technique for capturing the audio. Hi, my name is Dave Bodie for Tuts Plus, and in this course, you will learn about basic audio recording techniques, the different options you have for voiceover equipment, acoustic treatment, and how to properly use the gear. In addition to the technical aspect of this course, you will also learn about how to prepare for the read and how to work with clients to make sure that expectations are met on both sides. The techniques learned in this course can also be used in voiceovers for audiobook productions, audio podcasting, ADR or additional dialogue recording, and other multimedia projects. By the end of this course, you will have the skills that you need to be able to record voiceovers for your own productions, for your clients' productions, and you will have a great start on recording others for voiceover work. To start off, you are going to learn some basics of audio recording, starting with the next lesson. There isn't an industry standard voiceover equipment setup, but you will have to have a few pieces of gear to be able to get started. In this lesson, you will learn about the basic tools you will need, and coming up later in this course, you will learn about these different tools. To get started recording voiceovers, you will need a microphone, a recording device, editing software, headphones, audio or studio monitors, and accessories like stands and cables. The device you use to record could be something fairly simple, like a portable audio recorder. But if you're going to be recording near your video editing workstation, or any computer made in the last 5 to 10 years, you probably want to look into an audio interface to be able to record directly into your computer. This is a bit more convenient, as you don't have to worry about transferring files, shuffling memory cards, and you can get to editing straight away. You're also going to need a space that's relatively quiet to record. Unlike music recording, voiceovers are much more exposed. In other words, there's often not a tremendous amount of other sounds to mask noises you might have inadvertently recorded. This also means that if your computer produces noise from the cooling fans or the hard drives, you're going to need to record at some distance away from it so that you don't end up capturing those sounds. As you will learn later in this course, there's a huge range in the cost of microphones, audio interfaces, headphones, and other gear. A lot of sites out there will tell you that microphones that cost thousands of dollars sound vastly superior to inexpensive microphones, but this is false. Perhaps these claims are made to discourage people from getting into recording voiceovers by making it appear as though there is a high barrier to entry. The fact is that in the last 137 years since humans first started making recordings, there's been a tremendous advancement. In particular, the last 10 to 15 years has brought major sound quality advancements, with prices getting lower and lower. This doesn't mean that all equipment is cheap, it means that a lot more high-quality gear is well within your reach. You are going to learn about the specifics of what types of gear you want to look for later in this course. But for now, you are ready to move on to the next lesson, where you are going to learn the answer to the question, what is audio recording? In this lesson, you will learn about some of the essential terms and concepts in audio recording, like analog to digital conversion, sample rates, and bit depths. So, what is audio recording? Audio recording is simply the capturing of a sound source, the conversion from analog to digital information, and the storage of that information. The system used for recording, editing, and manipulating audio is often referred to as a digital audio workstation, or DAW. Now, a DAW doesn't have to be a specific thing, and it's really more about the system for recording, editing, and exporting the audio. This system includes components like a computer, an audio interface, audio editing software, And for music applications, a MIDI keyboard is very common. Multitrack recording is a term that you might come across when you're looking at different software applications. Multitrack recording is the ability to record and edit multiple sound sources to create one cohesive audio production. You can record several sound sources at once, or you can record one individual sound source at a time and put each new sound source on a separate track. Most of the recording software out there is going to be geared for multitrack recording and editing, but for voiceovers, you are usually only dealing with one single source at a time. For this recording process to occur, we need several things. You need a sound source, like a person speaking, and a way to capture that sound source, a microphone. A cable is then used to connect the microphone to a preamp, which amplifies the microphone's signal to a usable level. The preamp is connected to a device that converts the analog microphone signal to digital information, and this is called an A to D converter. Finally, you will need a place to store this data on a hard drive or memory card. All of that sounds a little bit complex, but once you see it in action, you will find that it's pretty straightforward. When the analog to digital conversion happens, there are two properties that determine the data stream's fidelity compared to the original analog signal. The sample rate, which is the number of times per second that samples are taken, and the bit depth, which determines the number of possible digital values that can be used to represent each sample. Let's talk about sample rates first. The base sample rate for music recording is 44.1K, or 44,100 samples per second. So why are there so many samples? Well, for sampled audio to reproduce the entire range of human hearing, the sample rate must be greater than twice the maximum frequency you want to record. This is known as the Nyquist sample theorem. Because our hearing range goes between 20 Hz and 20,000 Hz, we need a sample rate larger than 40,000 Hz in order to resolve the highest frequency. This signal must be filtered before sampling to cut off frequencies higher than 20,000 Hz. Otherwise, the audio will be degraded. In an ideal world, frequencies above 20 kHz would just be chopped off, but it's cheaper and easier to use a transitional filter to gradually attenuate the frequencies up to about 22 kHz. So doubling 22 kHz gives us our 44 kHz sample rate. Now there's more to this story, but those are the highlights. Most digital video gear uses a 48K sample rate. A 48 kHz sample rate is used because it's compatible with different frame rates used in video productions. DVD audio and high-definition audio for Blu-ray can be 96 kHz up to 192 kHz. I am mentioning them here because when you look at recording gear, you're going to see these sample rates listed in the specifications. Those ultra-high sample rates are not necessary unless your client specifically requests for them, but that's unlikely. I record everything at 48 kHz. This way, I am covered for video and audio CD standards. Now let's talk about bit depth. Sample rate deals with cutting up the audio in the time domain, but bit depth is a value that divides up the amplitude of the audio. The two most common formats that you will see are 16-bit and 24-bit. For 16-bit audio, we have a dynamic range of 96 decibels, and with 24-bit, we have 144 decibels. This doesn't mean that 24-bit audio is louder. It means that if a signal falls close to the noise floor, it will be better resolved or sound clearer in 24-bit compared to 16-bit. Recording at 24-bit will take up more space than 16-bit, but the difference is not huge when you consider how much storage we have in our computers. I record everything at 24-bit, and you should too. Don't confuse bit depth with bit rate. Bit rate is a description of how much data per second is required to store a file, which can be translated into how big the file is. It's likely that you have heard of bit rate when it comes to lossy compressed audio files, like MP3s or AAC files. Although you could record in MP3 or AAC format, you would never want to. The standard practice is to record in a lossless format, like WAV or AIFF. The bit rates in lossless formats are huge in comparison to lossy compressed formats. I could go into much more detail on sample rates and bit depths, but it's not really necessary. As long as you set up to record using 48K at 24-bit, you are good to go. In the next lesson, you are going to learn about signal-to-noise ratio. Signal-to-noise ratio is one of the most important aspects of audio recording. In music recording, a bit of noise can often be masked by other instruments, but with a single voice, you are much more exposed, and getting a good signal-to-noise ratio is critical. Signal-to-noise ratio, often abbreviated as SNR or S/N, compares the level of a desired signal to the level of background noise. Background noise can literally be noise in the background, but it can also be noise generated by your microphone, noise from the preamp, noise generated in the electronics in the analog to digital conversion itself, or external environmental noise, like an HVAC system. Noise is anything that's not the signal that you are trying to record. Getting more signal to noise means a cleaner, clearer sounding recording, and is a fundamental concept in recording. In digital audio, 0 dBFS, or 0 decibels full scale, is assigned to the maximum possible digital level. All levels that fall below this maximum will be given a negative value. For example, -10 decibels. 0 dBFS is also where digital clipping occurs. When the value of a signal is larger than the 0 dBFS maximum, the waveform gets clipped or squared off and can sound nasty. I'm going to go over this a little bit more later when we talk about setting levels. But for now, all you need to understand is that you cannot go above 0 dBFS. So how do you get a good signal-to-noise ratio? Well, to start, you want to record in a quiet environment. Sometimes this will mean that you will have to record when people and traffic are less active. Depending on your area, that could be early in the morning, late at night, or in the middle of the day. You want to make sure that you are away from large appliances that might be running and making noise, like refrigerators, dishwashers, laundry machines, and HVAC systems. You also want to keep away from smaller devices that produce noise, like computers and external hard drives. The other important element to getting a good signal-to-noise ratio is getting the microphone close to the sound source. The mic should be about 8 inches away from your mouth. As the mic gets further away, the direct sound of your voice is reduced, and the reflected sound of your voice bouncing around the room and the ambient noises that are in your space will be increased. This is a recording of the AKG C3000B from about 8 inches away. This is a recording of the AKG C3000B large diaphragm condenser microphone from about 12 inches away. This is a recording of the AKG C3000B large diaphragm condenser microphone from about 24 inches away. This is a recording of the AKG C3000B large diaphragm condenser microphone from about 48 inches away. Getting the microphone close to your mouth is really the most important thing. This is especially true with voiceovers. If you want to capture the dynamic range and subtle nuances of the voice, getting the mic in close is the way to do it. That said, you do not want to get the microphone a lot closer than 8 inches, because you will start to get some nasty side effects, like air bursts and mouth clicks. Getting a good signal to noise also means setting appropriate levels on your preamp. If you have isolated yourself from external noise sources as best you can, there will still be noise in your recording. This comes from the AD conversion, the preamp, and even the microphone, and this is called the noise floor. The noise floor is the measure of the signal created from the sum of all the noise sources and unwanted signals within your system. If you set the recording level of your microphone too low, the level of your voice will be sitting much closer to the noise floor of your recording system. When you bring up the level in post-production, you will be bringing up all that noise as well. What you would want to do instead is record with a signal that's far above the noise floor without clipping. This is done by turning up the gain on the preamp so you have a strong signal, usually with peaks around -10 decibels. As long as you are using a decent microphone preamp and have the microphone close, this will get the signal well above the noise floor, and you will get a very good signal-to-noise ratio. If you were using a microphone that had a lower output and a lower quality preamp, you would be pushing the preamp to a point where it will start generating audible noise. And this is also something that you don't want. This means that you have to have decent equipment, a relatively quiet environment, and good microphone placement in order to get maximum signal-to-noise performance. You are going to learn more about these specific things coming up later in the course. In the next few lessons, I will be going into more detail about the gear used for recording voiceovers, starting with the next lesson on computers and software. Audio recording can be done using very modest equipment, and you have a lot of options in relatively inexpensive audio recording software. In this lesson, you will learn about some of the things you want to consider in your audio recording system and the software you use to record and edit with. First, let's talk about the computer. Recording a single audio file and playing back a few audio files at the same time is pretty simple. To put this into perspective, let me tell you a little story. The very first computer I bought with my own money was back in 2004, and it was a Pentium 4 3 GHz with 1 GB of RAM. This computer was perfectly capable of recording 16 channels of audio simultaneously with my audio interface. If that 10-year-old computer could record 16 channels at once, recording just one channel of audio could have been done with a much slower computer. This means that almost any computer made within the last 10 years or so will work fine for recording voiceovers. That said, there are a few things that you want to look for in the computer system that you want to use. Because we are recording a stream of digital information, the computer has to be responsive and have a hard drive that is in stable and safe condition. Even older hardware can be very quick and snappy with a fresh install of the OS. You also are probably going to want a good amount of space on the hard drive to work with, but this will vary based on your needs. Although you can record on older hardware, I want to make some recommendations for a new purchase. First, you do not have to have a Mac. There is still this misconception that for recording audio, video editing, and Photoshop, you need a Mac for best results. On the audio side, I think this comes from the old days when Pro Tools was Mac only. If you didn't know this, a Mac has the same hardware as a PC, but usually costs a lot more. They are not any more stable and are not noticeably faster doing actual work. By actual work, I mean rendering out files or other processor-intensive tasks. For this kind of work, you need horsepower, and there's really no difference between a Mac and a PC in that realm. Now, don't get me wrong, I have nothing against Apple or Macs. I think they're very well-designed products, and they have some of the best customer support in the industry. The point is that you don't need a Mac to record. That said, if you are looking for a notebook for recording, Apple makes some very good products. For non-Apple PCs, I would recommend the quietest computer you can find if you want the computer in the room with you when you are recording. Most desktop computers have fans in them that are going to be too loud and will be picked up by the microphone. If you have a computer already, you might want to look at a fanless CPU cooler or very quiet fans with large heat sinks. This can drastically help the noise level in your space. Many laptops are technically capable of audio recording and editing, but if they have those noisy fans, they won't work. If you can't find a quiet computer, you might want to look at buying long USB and monitor extension cables and then move your computer into another room. This should help keep your space very quiet. For me and my system, quiet is key. I moved my workstation to my basement that sits just under my office. The workstation is actually sitting only about 4 inches below the floor, but the floor and the carpet makes it completely silent. 8 to 16 gigs of RAM should be plenty for audio recording and editing, with lots of headroom to multitask. A single hard drive will work fine for basic recording, but you could add a second hard drive for redundancy. SSDs are quiet and fast, but not necessary for this type of recording. Remember, a single channel of audio only needs to stream 140 kilobytes per second. Just about anything can handle that. For software, you have a lot of options. If you are coming from a video or photo background and you are an Adobe Creative Cloud user, you have access to Adobe Audition, and that's what you should use. Audition is a powerful application that will do everything you need and more. If you are just starting out, I would recommend an application called Reaper. Reaper is a multi-track audio and MIDI recording, editing, processing, mixing, and mastering environment, and that's what I've been using for the last 7 years. Reaper costs $60 USD for a personal license, and will do everything you need and much more. You've heard me mention Pro Tools already, and you may be familiar with that name. Pro Tools is the most well-known audio recording software out there, but many applications are just as good. I believe Reaper is just as good, if not better, but you don't have to take my word for it. Search some of the reviews of Reaper, and you will see that it stacks up well against all the other players out there. For now, you are ready to move on to the next lesson, where you're going to learn about audio interfaces. As I mentioned earlier in this course, one of the essential tools for audio recording is an audio interface. In this lesson, you will learn about some of the input and output options, monitoring options, and get some recommendations on what to purchase. So what is an audio interface? An audio interface is essentially a sound card with professional inputs and outputs. There are several kinds of professional inputs and outputs in the audio world, but there are only a few that you will want to be familiar with at this point. The first is a XLR connection. The XLR connector is a style of electrical connector primarily found on professional audio, video, and stage lighting equipment. The connectors are circular in design and have between 3 and 7 pins, but for microphones and audio gear, it's only 3 pins. These pins carry the signal from the microphone to the input point of your device. Pin 1 is ground, pin 2 is positive, and pin 3 is negative. Another connection type looks like this. This connection has many names like TRS, phone plug, audio plug, and 1/4-inch cable. It was invented for use in telephone switchboards in the 20th century, and is still widely used today both in its original 1/4-inch size and in miniaturized versions, 3.5mm, or approximately 1/8 inch, and 2.5mm, or approximately 3/32 of an inch. The TRS connector's name is an acronym that stands for tip, ring, and sleeve, the 3 conductive parts of this connection. This connection has many uses, and sometimes it can be a little bit confusing. For more professional headphones, this connector is used, and it carries the signal as left, right, and ground. On balanced outputs and inputs, this would be positive, negative, and ground. There are also mono or TS versions of this cable, which you may know as a guitar cable. These are the same size but only have a tip and a sleeve. Some pro audio speakers use the same 1/4-inch TS connector, but speaker cables are not the same as instrument or line level cables and shouldn't be interchanged. On interfaces and audio gear, you will see these 1/4-inch connections as inputs and outputs. They may be labeled as balanced/unbalanced. Balanced connections use 3 conductors for positive, negative, and ground, and unbalanced connections use 2 conductors for hot or signal and ground. An RCA connector, sometimes called a phonoconnector, is a type of electrical connector commonly used to carry audio and video signals. The name RCA comes from the Radio Corporation of America, which introduced the design in the early 1940s. These cables are used for many things, such as video, line-level audio, digital audio, speaker connections, and more. The use of high-quality cables is especially important when using RCA for a digital connection. So RCA, 1/4-inch TRS or TS, and XLR are going to be the connections that you will need to be most familiar with, but you may also come across SPDIF, Toslink, ADAT light pipe, MIDI, and word clock. Unless you need to connect other audio gear to your device, those connections are not essential. So as I mentioned earlier, an audio interface is a sound card with professional ins and outs. Your computer probably already has a sound card, but it isn't set up for plugging in a pro-level microphone with an XLR input. Could you use your built-in sound card for recording? Sure, but it's going to be much less complicated to get a dedicated device to handle all the inputs and outputs. Almost all of the audio interfaces you will come across are external and use one of 3 types of connection to the computer: USB, Firewire, or Thunderbolt. Several years ago, FireWire was the professional standard, but now is less common because the FireWire interface is not as common on computers. USB is probably what you want to shoot for because it's going to be the most common connection. At minimum, you are going to want to have one XLR input with phantom power, one headphone output, and one stereo main output. Depending on the interface, the headphone output could be a 1/8 inch mini headphone connection, but I prefer the 1/4 inch connection because it's more robust. Output connections can vary as well. Ideally, you would have balanced 1/4 inch outputs, but unbalanced and RCA will work. Most of the current products from companies like Behringer, Roland, Tascam, Focusrite, PreSonus, M-Audio, Mackie, RME, Avid, etc. will work fine. All the current products out there today will support 48K in 24-bit recording. Now at this point, you might be asking yourself, couldn't I just use a portable audio recorder with XLR inputs? Well, the answer is yes, you can. However, you will find that it's going to be a little bit more of an expensive option to get a recorder with high-quality preamps. If you do need a portable option, you might want to look at a recorder that works as an audio interface when you connect it to your computer via USB. This will make it more convenient to record when you are by your computer because you won't have to deal with batteries and transferring files. Not all portable recorders work as audio interfaces, so check out the product details if that's something that you're looking for. Now that you know what you want to look for in an audio interface, you're ready to move on to the next lesson, where you're going to learn about microphones. Talking about what microphone to use for a particular application is a minefield because everyone has opinions. In this lesson, you will learn about a few different types of microphones and get some recommendations on what to use. When it comes to microphones, there are a ton of options. Just one microphone company makes about 18 different large diaphragm condenser microphones. It's absolutely crazy. Before we get into drilling down into what you want to look for, let me first explain about the different types of microphones. Microphones convert acoustic energy, sound, into an electrical signal. The topic of microphones is complex, and for this course, we are going to focus on a few basic types of microphones. Microphones are often referred to by how they work, dynamic, condenser, or piezo, and by their directional characteristics, cardioid, omni, shotgun. Two of the most common types of microphones are dynamic and condenser. Dynamic mics are highly dependable, rugged, and reliable. Dynamic mics function just like a speaker, only in reverse. There's a small movable induction coil positioned in the field of a permanent magnet, and the coil is attached to a very thin diaphragm. When the sound waves move the diaphragm, it moves the coil in the magnetic field, generating a small electric current. This electrical current is the microphone's output. Because of their construction, dynamic mics are very common for stage use, where ruggedness is important, but they're also widely used in recordings as well. Dynamic microphones in general have a more limited frequency response compared to condensers. A condenser microphone uses a thin conductive diaphragm held close to a disc called a backplate. This arrangement basically works like a capacitor. When sound pressure acts on the diaphragm, it vibrates slightly in response to the waveform. This causes the capacitance to vary, which causes a variance in the output voltage. This variation is the signal output of the microphone. Condenser microphones are different than dynamic microphones for a few reasons. The diaphragm element is much lighter than a dynamic microphone, so it can respond very quickly to sounds. Because of this faster reaction time, the sound is said to be more transparent, and condensers are far more accurate than a dynamic microphone. Because of their construction and electronics, condensers are not as resilient to physical shocks and humidity compared to dynamic mics. Condenser mics have excellent sonic characteristics and are widely used in recording and live productions. All condensers require power, as they have electronics inside to make them function. Some condensers use a battery, but more often they will use something called phantom power. Phantom power in the context of professional audio equipment is a method for transmitting DC electric power through microphone cables to operate the active electronic circuitry. There are a few other microphone types, like ribbon and piezo. Piezo microphones are pressure sensitive and are sometimes called a contact microphone. Piezos are almost completely insensitive to air vibrations, so they are not appropriate for voice. A ribbon microphone works a little bit differently. An extremely thin sheet of metal or nanofilm of electrically conductive ribbon is suspended within the field of a permanent magnet. When vibrations hit the ribbon, it creates voltage by electromagnetic induction. Ribbon microphones sound fantastic, and they were the standard for recording and broadcast from about 1920 to 1950. However, ribbon microphones are very delicate, and they usually require a lot of preamplification compared to dynamic microphones and condensers, so they are not recommended. You are going to want to stick to dynamics or condenser microphones. All microphones have a polar pattern that indicates how sensitive it is to sound coming from different directions. An omnidirectional pattern responds to sounds in nearly all directions. A cardioid pattern looks like a fat heart and rejects sounds from directly behind the microphone element. Supercardioid and hypercardioid have a more narrow pattern in the front of the microphone, but start to accept sounds coming from the rear of the microphone element. A shotgun mic's pattern is very narrow in front and has a narrow response from the rear, but does a good job of rejecting sounds from the sides. For recording voiceovers, you are going to want to stick to cardioid or perhaps shotgun pattern microphones, because we want to use that directionality to reject any ambient noises and room reflections in your space. Knowing about the polar pattern in a microphone is important because it will help you decide if the microphone is appropriate for what you are trying to record. Directionality in a microphone can be a good way to focus in on your sound source, but directionality also causes something called proximity effect. The proximity effect in audio is an increase in the bass or low frequency response when the sound source is close to the microphone. This is good to know because it can help with some sound sources, and it can make other sound sources a nightmare to control. This is a recording of the AKG C3000B large diaphragm condenser microphone from about 12 inches away. This is a recording of the AKG C3000B large diaphragm condenser microphone from about 4 inches away. All of these microphone types and patterns will sound slightly different, but those differences can sometimes be very subtle. Some microphones are thought of as being more appropriate for certain types of voiceovers. For example, a radio announcer might use a big dynamic microphone and record with it really close for that fat, rich broadcast sound. A movie trailer voiceover might use a shotgun microphone for that super in-your-face, hyped sound. If you are just starting out and you want a great all-around microphone, I would recommend a large or small diaphragm condenser microphone. You can get all of those same types of styles from a large or small diaphragm condenser microphone, but you won't be locked into anything specific. A few dynamic microphones have a nice, natural sound and are great for voiceovers, but dynamics have less output compared to condensers, so they will need to be amplified more, and this might push a preamp up to where you might hear some noise. Condensers, on the other hand, have a nice juicy output, so you won't have to push them as hard, and as you will see, you can get very good results from an inexpensive condenser microphone. In the next lesson, you are going to learn about some of the differences between large and small diaphragm condenser microphones, and hear some examples of these mics in action. Everyone wants to use one of those large, fancy studio microphones to record with, but great recordings can be made with a small diaphragm condenser too. In this lesson, you will learn about the differences and hear some examples of how good inexpensive condensers can sound. If you're not familiar with microphones, you might be wondering what the difference is between a large diaphragm condenser and a small diaphragm condenser. Essentially, it comes down to how the mass of the microphone element affects the frequency response of the microphone. Because a large diaphragm is larger, it can have a higher signal output, a lower frequency response, and sound beefier when you are trying to take advantage of proximity effect. They also tend to have more off-axis coloration compared to a small diaphragm condenser. This means that the high-frequency response rolls off as you move away from the center axis of the microphone. This roll-off can actually be useful for taming sibilants and mouth noises, as you will learn in an upcoming lesson. Small diaphragm mics are more accurate and have less of that off-axis coloration. Because of the smaller mass, they can respond faster to changes, so they are said to capture transients better than large diaphragm mics. With all of that said, these differences are subtle, and what looks like a big difference on paper can be almost imperceivable to the ear. Also, microphone design can change the way a microphone behaves. The main thing to take away here is that there are differences in microphones, but they can be very subtle. The best way to get a feel for what works is to try out a few microphones. Let's check out an example of what a large and small diaphragm condenser sound like. In this first example, you are hearing the AKG C3000B large diaphragm condenser microphone. Audio recording is simply the capturing of a sound source, the conversion from analog to digital information, and the storage of that information. In this example, you are hearing a MXL 991 small diaphragm condenser microphone. Audio recording is simply the capturing of a sound source, the conversion from analog to digital information, and the storage of that information. In this example, you are hearing a Sennheiser K6/ME66 shotgun microphone. For this example, I'm positioned about 12 inches away, where previously I was positioned about 8 inches away from the microphone. Audio recording is simply the capturing of a sound source, the conversion from analog to digital information, and the storage of that information. In this example, I am using the Shure SM58 dynamic handheld microphone. Because this microphone is a dynamic microphone, it has considerably less output than all of the other microphones that you've heard. Because of the lower output, I've had to turn the gain on my preamp almost all the way up. Audio recording is simply the capturing of a sound source, the conversion from analog to digital information, and the storage of that information. It's hard to make specific recommendations because some voices will sound better with a particular microphone. If I were to buy another microphone, I would look for a large diaphragm condenser with a high output, low self-noise, and a flatter frequency response. I probably wouldn't spend more than a few $100 on it, as there are a lot of great microphones in this price range. I also would not hesitate to get a small diaphragm condenser if there was a good deal on one. We've covered a lot of ground with microphones, and in the next lesson, you're going to learn about some of the accessories you're going to need to set up these microphones properly. You're going to need a few more pieces of kit to get going, and in this lesson, you will learn about microphone stands, pop filters, and XLR cables. First, let's talk about microphone stands. You will find a few different styles of stands out there, but I would recommend a tripod-style stand with a boom arm. The tripod legs will give you more stability compared to a round base stand. This will help if you are using a boom arm with a larger mic and a pop screen. I would recommend getting something that is a bit better than the cheapest stand out there, as stability is important. Condenser mics are delicate, and you don't want one toppling over because you went with the cheapest stand you could get. I like this old Tama MS205 stand. This was my wife's stand that she used with her band, and it's 16 years old. A good stand will last many years, and it's a worthwhile investment. K&M and Ultimate Support also make very high-quality stands. I would look for a unit with a really beefy-looking clutch and a metal support arm and lots of other metal parts. Expect to pay between $50 and $100 USD for a quality stand. If you're going to be working at your desk a lot, you might want to consider a desktop microphone stand. You can actually get a short, round base stand, but you may find that this is in the way a lot of the time. Another option is a swiveling desktop boom stand, like the Rode PSA-1 or the Heil PL2T and HB-1. These types of stands can be clamped or screwed to your desk and be moved in and out of position very easily. This is another area that you do not want to skimp on, as you will be moving the stand quite a bit. A lighter-duty, cheap version of this type of desktop stand won't be able to handle the weight of a larger microphone and will constantly sag and move out of position. Because I record voiceovers at my desk and I use a standing desk, I have an interesting solution for mounting my microphone. You've seen it behind me throughout this course, just over my shoulder here. I took a short desktop stand and put a boom arm on it. Now, normally, this wouldn't be stable with the boom arm and microphone, but I put a 10-pound weight on the base, and in this configuration, it's perfectly stable. This gets the microphone right where I like to have it and out of the way of all of my screens. I like to have a boom stand on hand as well, and I will show you how to set up the microphone on a boom stand later in this course. Next, let's talk about a shock mount. A shock mount is a device used to hold the microphone and elastically isolate it from the mic stand. Usually, these have three main parts. There is an inner frame that holds the microphone and an outer frame that attaches to the microphone stand. Elastic bands are used to isolate the inner frame from the outer frame, allowing the inner frame to move without touching the outer frame. Shock mounts are commonly used on studio microphones to prevent unwanted noise by isolating the microphone from variations that might otherwise be transmitted through the microphone stand. Without a shock mount, the microphone is much more sensitive to vibrations, and this can lead to a lot of problems in your recordings. This is especially true of large diaphragm condenser microphones like this guy right here. A lot of large diaphragm mics will come with a shock mount. Some have a special threaded mount that only works with a specific shock mount, and other microphones like my AKG C3000B can be used with a regular mic clip, but again, you're going to want to use a shock mount when you are recording. If you are using a different type of microphone, like a small diaphragm condenser, dynamic mic, or shotgun mic, a shock mount is also recommended. You can find shock mounts for these smaller diameter microphones for $10 to $15 USD online. If a large diaphragm mic didn't come with a shock mount, these can be picked up for between $15 and $50 USD, depending on the size and shape of the microphone. Another essential accessory is a pop filter. A pop filter, or pop shield, is an anti-pop noise protection filter for microphones, typically used in a recording studio. The job of a pop filter is to stop the air bursts caused by the mechanical impact of fast-moving air on the microphone. These air bursts come from aspirated plosives, like the P's in the word puppy. It also has the secondary benefit of blocking spit and saliva from hitting the microphone element. A typical pop filter looks like this. You have some sort of acoustically semi-transparent material, like woven nylon, stretched over a circular frame. The frame is connected to a flexible mounting arm and clamp. Metal pop filters use a fine mesh screen in place of the nylon. You can DIY a pop filter that will work exactly like a professional unit by stretching tights or stockings over an embroidery hoop or a loop of wire such as a bent coat hanger. It's important that the pop filter is not attached directly to the microphone, as vibrations will be transmitted from the filter to the microphone. Usually, pop filters are attached to the microphone stand. A pop filter is not the same as a windscreen. Pop filters are generally used in a studio environment, while windscreens are typically used outdoors. Windscreens do provide some protection against air bursts and saliva, but they may not be as acoustically transparent as a studio pop filter. Lastly, you're going to need an XLR cable to connect your microphone to the input of your audio interface, preamp, or portable recorder. When it comes to audio cables, I like to make my own, but I understand that not everyone enjoys that sort of thing. My advice when buying cables is this: buy long and to get decent quality. I like to have mic cables that are a little bit longer than I think that I need. Too short almost never works, but too long as it's not 20 feet too long, isn't usually an issue. There isn't any appreciable signal loss with a few extra feet of cable, so that's what I usually go for. I also like to get cables that are of decent quality. An XLR cable is pretty simple, but you want to make sure that it's using quality cable and quality connectors. I like connectors from Nutric and Switchcraft, but most of the cables that I've ever come across have been Nutric connects. When I'm buying cables for a project, I usually go with CBI, Proco, Rapco, or Whirlwind cables. Now that you know what accessories you need to set up the microphone, you're ready to move on to the next lesson, where you're going to learn about monitors and headphones. Studio monitors and headphones are essential for monitoring your recording, mixing, and editing. This is another area where it's easy to get lost in specifications and options. Fear not, in this lesson you will learn what to look for and get some recommendations for specific gear to use for your productions. Speakers and headphones for recording are a little bit different than your home theater speakers and your DJ headphones. Speakers and headphones designed for music playback tend to have more of a hyped sound, meaning the high and the low frequencies are a bit louder to give everything a more pleasing sound. For recording purposes, you want your monitor speakers and headphones to be neutral sounding, so that they are giving you an accurate representation of what you are recording, not a sweetened version. This accuracy is going to cost you a bit more than your basic set of bookshelf speakers or your average DJ headphones. Now technically, you could get by only using good headphones, but you'll probably want a set of studio monitors as well. Headphones are going to be essential for monitoring your recording. If you are recording in the same room as your studio monitors, you can't use them to monitor the recording because you will cause a feedback loop and damage your speakers and probably your hearing. For this reason alone, you have to have a set of headphones. Headphones also come in handy when you need to edit late at night, or when there are other noise sources that are intruding into your space. If you never intend to mix or edit using your headphones, you could get away with using just about any set of closed-back headphones, or even good-sounding earbuds or in-ear monitors. The idea is that you don't want headphones that leak sound, as that would color the recording. I would also recommend a circumaural headphone style, which go around the entire ear. These are far more comfortable than the supraaural, which sits on top of the ear. Giving a specific recommendation is tricky because there's going to be some personal preference and comfort involved. I have 4 sets of headphones, and the ones that I like the best came from monoprice.com and were pretty cheap. I like them because they have a fairly neutral sound. They are comfortable on my ears, and they are cheap. When it comes to headphones, there can be a several hundred to few thousand% markup. This makes me feel like when I find an inexpensive set of cans that I like, I'm sticking it to the man, and I like that. All the big names like Sony, Sennheiser, Audio-Technica, AKG, Beyerdynamic, and Shure make good headphones. You just have to find the right pair for you. I have read good things about the Sennheiser HD 280 Pro, which cost about $100 USD, and the Sony MDR 7506, which cost about $85 USD. Usually, open-back headphones are recommended for mixing and editing, but again, these will not work well for recording. If you're going to get one set of headphones for recording, mixing, and editing, you might want to get a nicer set of closed-back cans that are going to last you a long time. For monitors, there are 2 main options: active or passive. Active monitors have amplifiers built in, so all you have to do is plug them in to power and connect up your audio interface. Better active monitors use bi-amplification, which have a separate amplifier for the tweeter and for the woofer in each speaker. Passive speakers require a separate amplifier. The trend in monitors for the last several years is active speakers. These monitors come in several different sizes, but I would recommend that you shoot for something that has a 6 to 8 inch low-frequency driver. For editing and mixing your voiceover, you don't need a ton of bass, but without bass, you will be missing a critical part of the audio spectrum. It's hard for smaller speakers to generate those low frequencies because they don't have enough surface area to move a lot of air effectively. If you're looking for monitors to edit your voiceovers and do some mixing, you're going to want to make sure that you get something pretty decent. I would expect to pay between $250 and $600 USD per pair for something decent. You might check out brands like PreSonus, KRK, Yamaha, Mackie, and M-Audio. Even Behringer has some monitors that are an exceptional value and offer a lot of bang for the buck. If you're just getting into recording and you pick up your first set of monitors, you might not like the way they sound at first. They might sound dry or dull, but this is completely normal. The point is that they should reveal things in your mix and give you an honest representation of what's happening in your audio. A big thing to remember here is that you can become proficient at mixing and editing using almost any speakers and headphones. The key is that you have to reference a lot of different high-quality material so you can get an understanding of what good recordings sound like on your system. This can take some time, but once you learn how to mix and edit with your monitors and headphones, the whole process becomes easier. I used to own a set of Mackie HR824 monitors, which cost me about $1,400 USD. These were really nice monitors, but I eventually sold them to get out of debt. A short while later, I bought these Behringer Truth 2031A monitors, which look a lot like the Mackies. I've been pretty pleased with their performance, but if I had to do it again now, I would probably go a different way. The other monitors that I use are these older Alesis 0.7 monitors that are on permanent loan from my brother. These are a passive speaker that I use for gaming with a 5.1 setup, and I don't use these a whole lot for mixing. But I do check my mixes on these speakers from time to time. I wanted to share my experience with monitors with you because I want you to understand that you can get good results on gear that isn't in the top of the price spectrum. If you need a specific recommendation for your first set of monitors, I would check out the PreSonus Aris E5 or the Yamaha HS5 because these are very well reviewed and highly rated. Placement of your monitors is something that you will want to consider as well. It's best to have the monitors on monitor stands. Setting the monitors on your desk will color the sound of the speakers because they will vibrate the surface of your desk and that will cause some frequency cancellation. If you need to mount them on your desk, you might consider placing them on a 1/2 inch or 3/4 inch piece of open cell foam or neoprene, or a dedicated monitor isolation pad. A monitor isolation pad is a good idea for your monitor stands as well. This will help to decouple the monitors from the floor and help improve the bass response. It's recommended that you set up your monitors in an equilateral triangle. If you are 4 feet from your monitors, they should be about 4 feet apart. Now, this doesn't have to be exact. In fact, a lot of people feel that a wider spacing of the monitors works a little bit better. The tweeters should be at ear height, and the monitors should be pointed at your ears to get a good left-right image. Sometimes aiming the speakers a few inches behind your head can widen the sweet spot, so you will have to experiment with this to find out what works best for you. Now that you have an understanding of headphones and monitors, you are ready to move on to the next chapter in this course, where you're going to learn about controlling the sound. So, where should you record your voiceovers? Will your office or your bedroom sound okay? Or will it need some treatment to help the situation? In this lesson, you will learn about the pitfalls of setting up your microphone in an untreated space. As you've already learned, getting the microphone close to the source is important for reducing ambient noises and room reflections. The problem is that even if you get the microphone close, you're still going to hear some room reflections in your space. This is essentially reverb. You are hearing the sound of your voice bounce around the room until it loses energy. Let's look at an example. For this demonstration, I've moved my microphone setup into a bedroom so you can get an idea of what an untreated space sounds like. Now, this room does have carpet on the floor, and it does have a large queen-size bed in here with your standard pillows and comforters, but the walls are untreated. Now, you might have heard that a clothes closet can be a good place to record. The idea behind this is that the clothes will soak up the sound of your voice. Depending on the size and the shape of your closet, this may or may not work. It's probably better than recording in an untreated space, but it's also adding room reflections that you might not notice right away. The clothes do absorb some of the frequency spectrum, probably in the upper frequency range above 500 Hz. Below 500 Hz, they don't absorb a whole lot of energy. What happens is, the relatively small space reflects a lot of that low energy back into the microphone. This will color the sound of the recording. Let's check out an example. So what you're hearing right now is the same setup that's been used in previous examples. I'm using my AKG C3000B on a boom stand about 8 inches away from my face, but now I've moved my whole rig into a closet that is full of clothes that are hanging up on the wall. Now, this type of setup might work for you, and you might like the way that the reflected sound helps to give your voice a little bit more body. I think more times than not, this makes the voice sound muddier. Plus, small spaces can have a lot of variation in what frequencies are being reflected back to the microphone. If you want more beef or body in your voice, you can do it selectively with an EQ adjustment, or by moving the microphone a little bit closer to your face, which is probably a better idea. Another option is a porta-booth solution. These are small, arc-shaped devices that are meant to be placed just behind the microphone. The goal of all of these types of products is to minimize the capture of room reflections from the source being recorded. These products use absorptive materials to reduce room reflections by absorbing the sound before it can get out into the room. They also help to attenuate some of the sound of those room reflections from reaching the microphone. The biggest question is, do these types of devices work? And until very recently, there have been no formal tests of any of these products. In fall of 2014, Sound on Sound magazine teamed up with the Acoustics Laboratory at the University of Salford. You can check out the very detailed test results and the full article on the SOS website, but the main takeaway is this. All of these products, at best, only help a little. This is due to the fact that they are not very big, so they don't have a lot of mass, and they are meant to be positioned close to the microphone, which causes a lot of coloration. A better option would be to try to help the situation with a much larger broadband absorber behind the performer to absorb those reflections that would be bounced back into the sensitive side of the microphone. The larger, the better. This will have a much more obvious effect compared to one of these portable booth solutions. Additionally, you might think about treating your entire space where you record and edit. The benefit of this approach is that the recordings will sound better, and the editing/mixing space will sound better to work in. The same room reflections that are causing problems when you are recording are also causing problems when you edit. So it makes a lot of sense to treat the entire room and kill two birds with one technique. In the next lesson, you are going to learn about some commercial solutions and a DIY solution to treat your space, and where to place this treatment for maximum effectiveness. Acoustic treatment panels absorb sound and cut down on echo. Installing them can make your space much easier to work in for both recording and editing. In this lesson, you will learn where to position acoustic panels for a neutral sounding recording. When it comes to acoustic panels, a lot of people think of foam. You've probably seen foam panels in pictures and sold in music instrument retailers' recording department. The problem with foam is that it doesn't offer any meaningful absorption below 1 kilohertz. Using foam for sound treatment is not effective because you will still have an issue with low frequencies. A better material to use is rigid fiberglass insulation or mineral wool. I prefer mineral wool because it offers very similar, if not better, absorption properties, it's less irritating, and it's more cost-effective compared to fiberglass. Mineral wool, also known as mineral fiber, rock wool, or stone wool, is a product that is made from molten rock that is spun into a fiber in a process similar to making cotton candy. It looks similar to fiberglass but is more dense. 2-foot by 4-foot rigid mineral wool and fiberglass boards are the two most common types of materials used for commercial sound absorption panels. Most of these products are frames made out of wood or metal that go around the outside of these boards. The frame provides a place to attach hardware for wall mounting, and then these panels are wrapped in fabric for a nice finished look. These panels are quite easy to make, and you can check out a few tutorials that I created on photo.tutsplus.com for more information on how to make your own. The panels can be made for a fraction of the price of commercial panels, but I understand that the DIY solution is not for everyone. Before you figure out where to place your panels, you want to make sure that you are positioned at the optimal spot in the room. The listening position should be about 38% back from one of the short walls and centered between the two long walls. If you can't get your listening position exactly at 38%, just make sure that it's not at the 25, 50, or 75% positions, because at these positions you will experience huge peaks and dips in the low frequency response. Once you settle on a listening position, your next task is to create a reflection-free zone. The reflection-free zone, or RFZ, is a pretty simple concept. The idea is to prevent early reflections, also called first reflections, from interfering with the direct sound from the speakers. This interference happens when the sound arrives at your ear at more than one time. One of these sounds comes directly from the speaker, and the other comes from the sound of the speaker bouncing off the walls and hitting your ears at slightly different times. You might not think that this makes a huge difference, but it can be very dramatic. In order to determine where the RFC is, get into the listening position and have a friend take a mirror and hold it up to the wall. Any place that you can see either part of the right or the left speaker needs to be treated. The ceiling is also part of the RFC and should be treated as well. You can find the position here by using the same method, but this can sometimes be a little bit difficult. Instead, you can hang the panels just above the listening position or along the same axis as the side panels. When I mounted these 4 panels in my room, I noticed an immediate improvement in the sound. Everything coming from the speakers sounded tighter, clearer, and the imaging between the right and the left speaker improved tremendously. Outside the RFC, you also need absorption. Depending on the size of your room, this can be as much as 50 to 30% of the untreated wall space. Smaller rooms will need more. The panels should be spaced evenly in the room and offset so that the panel on one wall is pointed at the space between panels on the opposite wall. This will help to prevent a flutter echo between parallel walls. Some rooms are going to be a little bit more complex than your average rectangle, and you will have various challenges in placing your panels, but the idea is to be prepared to add enough panels to make the space work. Just treating the RFC and adding a few more panels is going to make a huge difference in the way the room sounds. Like I mentioned before, the benefit to treating the room is that now it sounds much better for editing and mixing and recording. Let's say that you did some room treatment, but you were still hearing a little bit more room reflection than you wanted to. Here are some options. If you have any panels left over, you can take a panel and rig it up so that it is positioned just behind you when you are recording. As long as your panels are not super heavy, a photographic light stand would work well for this as they are pretty strong and lightweight. Alternatively, you can take a few moving blankets and hang them just behind you when you record. To hang them, you could get a sturdy piece of PVC pipe or even a shower curtain rod and clamp the blankets to the pipe. To support a large rod with a fairly large curtain, you're going to need a pretty beefy stand. I like to use a C-stand with a grip head and boom pull hanger to hold this shower curtain rod. With a sandbag or two on the bottom, this is a very stable and safe solution. If you position this a few feet behind your recording position, it will make a big wall of sound absorption. It may not work very well in the lower frequencies, but as long as you are a few feet away from any walls, this should work very well. Now that you understand the basics of treating your space for editing and recording, you are ready to move on to the next chapter in this course. In the next chapter, you are going to learn how to prepare, set up, and record your voiceovers. So check that out coming up next. In this lesson, you will learn how to prepare for recording voiceovers. This is not rocket science, but these simple steps will help to make the process much smoother and save you time. The first thing to do when you are getting ready to record is read through the script at least once, if not a few times. This will help you develop a flow, and it gives you a chance to practice any tricky passages before you are recording. You are also going to want to look up any words that you do not know how to pronounce. For American English, a good pronunciation resource is the Merriam-Webster Online Dictionary, which includes audio examples. If there is a product or a company name that you don't know, call the company's customer service and ask about it. YouTube is another good resource for pronunciations of names and places. You want to practice reading the script with the right tone and attitude for the project. In a sense, this is a performance, and you need to practice it in order to get the right vibe. If you are reading from a paper script, you're going to want to put it on a stand positioned pretty high up so that you are not looking down away from the microphone. Holding the paper may result in unwanted noise from the paper rustling, no matter how hard you try and hold the paper still. If you are reading from a tablet or smartphone, double check that you have put these devices in airplane mode temporarily. Sometimes, the radios used for data in these devices can cause some strange interferences when they are in close proximity to microphones and audio cables. It will also help to make sure that distractions are minimized so that you can focus on your performance. Have the temperature set at a comfortable level for the space. You will probably have to close the door to whatever room you are working in, and this may cause the heat to build up. If this is the case, you might want to aim for a bit cooler to compensate for this effect. If you are recording solo, you want to be on the lookout for mistakes when you are in performance mode. Stopping every time you make a mistake will sound unnatural, and it'll be harder to patch back together in the edit. You will probably want to record a few takes of the script to make sure you are getting everything you need. If you have to go back and patch up any lines, make sure you start at the beginning of the sentence or thought idea so that it makes for a more natural flow in tone and speed. This will make it much easier to edit back together in post-production. Using these techniques, you will be able to record a great performance without missing any critical information. Now that you are prepped for the recording, you are ready to move on to the next lesson, where you will learn about setting up the microphone. In this lesson, you will learn exactly how to set up the microphone to reduce plosives and get a great signal-to-noise ratio. For recording the voice, I like to set up the microphone above my head so that I can look down slightly at a script. If this is uncomfortable for you, you could position the microphone just below the mouth so that you can see over top of it. You would think that you would want to point the microphone directly at the mouth, but it can work better to angle it above or below the mouth. Angling the mic like this further helps to protect against air bursts and helps to reduce mouth clicks and other mouth noises. But you'll want to experiment with this technique to see what works best for you. You want the microphone about 8 inches away from your mouth. If you get in closer, proximity effect will start to become apparent. Positioning the microphone further away will result in more of the room sound being captured. Microphones with a super tight pickup pattern, like shotguns, can be placed a little bit further back. You want the pop filter a few inches from the microphone in order for it to work properly. If it's too close, the effectiveness of the filter will be reduced and you may still have air bursts. You want the rest of the pop filter hardware to be out of the way so that it isn't interfering with the sightline to the script. The mic cable can be draped over the microphone stand to get it out of the way. Technically, the microphone cable can transmit vibrations to the microphone because it's connected directly to it. Touching the microphone cable to the mic stand increases the risk of vibrations from the stand being transmitted to the cable and then to the microphone. What I like to do is gently drape the microphone and not wrap it around the mic stand. When it's gently draped, it's only touching the microphone stand in a few very small spots, so the vibration risk is reduced. You also don't want to position the cable in a spot where you are standing on top of it or tripping over it. I also like to put a little strain relief when I plug the cable into my interface. I do this by creating a little slack and then have the cable come into the interface from a nice, gentle arc. Cables can be damaged if you bend the cable very severely. XLR cables are quite flexible, but I like to be extra safe. This also protects the input of the interface from being damaged if the cable gets snagged or pulled. This kind of force can damage the solder joints on the XLR connector, which will need to be repaired. Before you plug in your microphone cable into your interface, make sure the gain is down and your speakers are off so that you don't cause a feedback loop. Now that your microphone is set up properly, you are ready to move on to setting levels, which is coming up next. Setting levels is a balance between a strong signal, reducing noise, and avoiding clipping. In this lesson, you will learn how to set levels for your recording. Setting levels is pretty simple. Again, before you plug in your microphone to your interface, make sure your speakers or any other amplifiers are off so that you don't cause a feedback loop. I like to turn the microphone gain all the way down as well just to be extra safe. When I first got into recording and audio gear, I left the amplifier on and flipped an input switch on a mixer. The studio monitors went into instant hardware feedback and the tweeters blew. I will never forget that, as it scared me so bad I could hear my own heartbeat. If you are using a condenser microphone, make sure phantom power is turned on. You may also want to look at the documents of your interface or preamp to see if there is any specific instructions for turning on phantom power. Some nicer preamps ramp up the voltage on the phantom power, which can be a little more gentle on the electronics in a condenser microphone. I have never had a problem plugging in a condenser mic and then hitting the juice, but it might be worth checking that out. When it comes to setting levels, you do not need to record a super hot signal and ride the gain knob. If you are just starting out, you might want to set the levels so that you are peaking at around -10 decibels on the meters of your recording software. Peaks are the loudest segments, and there is usually an indicator of the peak level, so you'll be able to easily see where you are at. You're also going to want to work the microphone as much as possible. Working the microphone is a technique where you physically move your head back for louder passages and get a bit closer for quieter passages like whispers. Working the mic like this will help the leveling later in the edit process, as the overall levels will be much more consistent. You don't want to clip the recording level, so if you are seeing peaks that are getting close to -6 or higher, you're going to want to back down the preamp a little bit. A tiny bit of clipping may not be noticeable and can be recovered to a degree in post-production. You don't really need to record a super hot signal anyway, because the noise performance on modern equipment is very good. The best idea is to play it safe and keep those peaks around -10 decibels. Now that you know about setting levels, you are ready to move on to the next lesson, where you're going to learn about how to prep your mouth, vocal cords, and throat. When you start recording voiceovers, you may notice some strange mouth noises. This can be avoided with a bit of clever hydration, and in this lesson, you'll find out how. Like I mentioned before, you may be working on the voiceover for a while, so make sure you've created a comfortable work environment. Another thing to have on hand is some kind of mouth lubricant. I know, that sounds a little bit funny, but it's critical that the mouth not be dry when you record. A dry mouth causes all manner of clicks, clacks, and other rather off-putting mouth noises. I found that having a room temperature beverage that is a little bit tart works really well for me. When I take a sip, it causes my mouth to water and really helps with the mouth noises. Tea with honey and other tart fruit juices can work as well, as long as the fruit juices are pretty diluted in water. Anything carbonated should be avoided for obvious reasons. Other super sugary drinks can actually make the mouth feel more dry, so they should be avoided as well. There are also some throat coat sprays that contain some glycerin that may help to keep the mouth and throat nice and wet. My personal favorite is berry-flavored Propel powdered mix, mixed in with some water. This is nothing more than a water flavoring, but I like the taste of it, and it's just tart enough to get the juices in my mouth flowing. Another thing to be aware of is the general humidity in the space. Many places around the world experience seasons where the humidity can fluctuate wildly. Forced air systems can also feel very dry to the mouth and throat, so you may want to consider setting up a humidifier to bump up the moisture content in your space. This isn't something that you can have running while you record, but it can make a big difference to the comfort level of your space and your pipes. Now that you know about proper mouth lubrication, you are ready to move on to the next lesson, where you are going to learn about recording silence. Recording a bit of room tone can be a big help in the edit process for cleaning up noise and pasting in sections in the edit. In this lesson, you will learn why it is important and how to record the room. Room tone is the silence recorded at a location or space when no dialogue is spoken. This seems like an odd concept, and I must admit, when I first heard of this, I didn't fully understand the point of it. Recording room tone or silence can be a valuable tool for your projects. First, it can help you to better tackle noise reduction in post-production. The type of noise reduction I am referring to here is broadband noise, which is different than a dog barking outside. Noise reduction is not something that you will want to use a whole lot because it can cause some nasty sounding artifacts, but sometimes it's unavoidable. Depending on the conditions of the recording or the location, you may have recorded some noise that needs to be dealt with. Recording 10 seconds of silence at the end of your session will give you an additional tool to be able to tackle this. Sometimes, when you're in the recording zone, you are pushing to get through a script. In the edit process, you will have realized that you need to do a little bit of noise reduction, but there isn't a good spot to be able to sample the noise from because you were in such a rush. Taking a few extra seconds and recording silence at the end of your recording can be exactly what you need to be able to fix this situation. Because these sorts of noises can change at different times of the year, it can be a good practice to do this every time you record. This silence can also come in handy in the edit process, where you have to slice and dice a section of your recording. Sometimes you have to adjust the timing of a passage, and when you do, there will be nothing to fill in the gaps. Having the audio drop out completely in these sections can be distracting because you will notice the absence of the room tone. In these passages, you can use your 10 seconds of silence and patch it in to fill the gaps. This is subtle, but it might be what's needed to glue parts of the voiceover together. And the more engaging you can make your voiceovers, the better off the project will be. In the last chapter of this course, you will learn about working with clients, and you will get some final tips and tricks for producing great sounding voiceovers. Check that out coming up next. Congratulations! Someone heard one of your productions and wants you to record a voiceover for their project. In this lesson, you will learn the things that you want to go over with your client so that the experience is positive for everyone involved. Working to create a voiceover for someone else can be stressful, but it doesn't have to be. The path to success is to make sure that you are going over as many details as you can to make sure you and your client have the same expectations. Here are some of the things that you will want to talk about up front. When is the deadline? You want to make sure that you have adequate time to record, edit, and make any revisions to the project before you say yes. It won't matter how good the recording or performance of your voiceover is if you miss the deadline. What is the VO for? Understanding the project in a little more detail can help you dial in your performance. What is the tone and the speed of the read? Is this a friendly, slow read, or does it need to be a little bit quicker and have some attitude and edge? You may want to ask for a reference so that you can get an idea of what the target sounds like. If you can't get a reference, you may want to record a 5-second portion and send it out to make sure you are on the same page. As you get more experience recording voiceovers, you will probably have amassed material of your own to use for references. What sample rate and bit depth are they looking for? 44.1K or 48K, 16 or 24-bit. You can still record to 48K and 24-bit and render out your tracks down to the specs. This is something that you don't want to assume, as that can cost you time re-rendering tracks and sending out new files. Along those same lines is what types of files should be sent out. Are they looking for WAV, AIFF, MP3, AAC, FLAC, or something different? If you are recording a long voiceover, you may want to send out a compressed file along with the master file so that they can get it faster or listen to it while they're on the road. In this situation, I would send out a 320 kilobit per second MP3, as it's the most universal and can be played in a browser on many mobile platforms. Just make sure they know that the MP3 version is not the master file. Ask about any file naming conventions. Some people need a very specific file naming system to integrate with their workflow. You may have your own clever naming system for files, but you want to make sure you are sending out the files with the proper name the first time around. How much editing needs to be done to the recording? You are probably going to want to edit out all of your mistakes, remove any areas of silence, and do some very light EQ and processing. But you want to ask how much more processing they want done to the files before it goes out. If the files are going to be used in a larger project, they may have their own editors that are going to work on the tracks. Or you could be giving them files that are going to be used in something like a website or a mobile application just as they are. In this case, you want to make sure that they are processed appropriately. How is payment being handled? First, you want to make sure that everyone is on the same page with the financials of the project. If you usually charge a flat rate for recording and an hourly for revisions, make sure that is in writing and sent to the client. This can be a hot mess to try and sort out after you have sent out the final files. You also want to make sure that you can accept the payment that they are going to use, and that they might be using net 30 to pay you, which is 30 days from when you invoice. This gives your client time to invoice their clients and get paid, and then break you off your cut. Finally, do not record until you get the green light from your client, and hopefully a deposit. I know you are excited to record and you want to do a great job for the client, but hitting the record button too early can lead to extra work more times than not. Personally, I like to get a deposit in hand before I start work, unless I have a personal relationship with the client and can make a personal visit if they don't pay up. Asking for a deposit shows your time is valuable and it gets the ball rolling in the right direction. Getting these details sorted out before you start on a project is just smart. This way, you have an expectation to meet and the client has an expectation of exactly what you are going to do for them. In the last lesson of this course, you will learn about some final tips and tricks that you can use to make all your voiceovers a success. Thanks very much for watching this course. In this last lesson, you will learn some final tips and tricks that will help all your voiceover recordings sound excellent. Remember that good file organization and backups are important. This isn't specific to voice recording, but it's just good practice for any multimedia project. I use the cloud and multiple hard drives to back up important projects, and sometimes I will burn files to a DVD as well to make sure I'm covered. As you have seen throughout this course, it's easy to dump a truckload of cache into microphones, interfaces, monitors, headphones, and other shiny gadgets. But you really don't need top-end gear to make great recordings. What's most important is treating your space and making sure that you are capturing a good performance. High-end gear in a poor-sounding room will sound terrible no matter what it costs. Using a simple dynamic microphone and a basic audio interface in a super dead room can sound fantastic. Thanks again for watching this course. I hope the things that you learned will help you to create high-quality, engaging voiceovers. For more great audio courses and tutorials, check out some of my other courses on tutsplus.com and music.tutsplus.com. Again, my name is Dave Bodie for Tuts Plus. Thanks so much for watching, and I'll see you around.